So next is wiring the S7-1200 and wiring types. Now we have different wiring types. First we have syncing input. Now what happened in syncing input, just notice here we have, this is the same way, we have connected 0 volt to my 6 to my common, and 24 volts is coming to my inputs. This is called syncing inputs. Syncing input means you are providing 0 volt to your common terminal. Okay. The another type is sourcing input. Now in sourcing input, what we have done is, okay, this is the same syncing input. If the switch is open, the input is not on. If switch is closed, the input is on. Okay. Another type is sourcing input. In sourcing input, see, we have a change in the wiring. We have connected 24 volts to my common terminal instead of 0 volts. Here it was 0 volts, but we have connected 24 volts. This is called sourcing input. Now we have to connect 0 volt to my inputs to energize it. So the switch is open, this is not on. If switch is closed, this is on. Now why we have two types of wiring? What is the reason? So the reason is sometimes we have different types of sensors. So if we are using this type of wiring, we can use PNP sensors. PNP sensors provide you generally 24 volts in your PLC. So if you are using PNP sensors in your operation, in your process, you must do syncing inputs. You must use syncing input wiring. Okay. If you are using NPN sensors will give you 0 volts. Okay. In that case, you have to do sourcing input types of wiring. You have to make sure if your inputs are NPN, you must connect 24 volts to your common. If your input sensors are PNP, you must connect 0 volt to your common. That's the only reason why we have two types of wiring. Okay. So if you're already PLC is wired with syncing input, if it is already having 0 volt to the common, you must order the PNP sensors if you're going to buy the sensors for your PLC, because there are just one common in all the inputs. There are no second common. You have to make sure what you're doing with the wiring. Before purchasing the sensor, make sure you know what is the type of wiring already done in your PLC. Okay. So moving ahead, output wiring type. Similarly, we have output wiring type. First is AC load, which is up to 2 ampere. So up to 2 ampere, you can directly connect the output, just like I've shown you in the last slides. This is the line going here, and this is the output directly connected to the indicator if its load is less than 2 ampere. Now, what does it mean? Now, load of 2 ampere means if your output draws a current of 2 amperes. Okay. For example, a motor running, without any load draws 400 watt motors draws 0.6 ampere or 0.4 ampere sometimes. Okay, when motor is on load, it may take 1 ampere or 1.5 ampere. So if its value is within this range, you can connect directly to your PLC. Okay, if your value is beyond 2 ampere, what you will do? Do you have to take another PLC? No, there are alternatives. You can connect another relay. Okay, now this is a symbol of a coil of a relay. So let me use a pen. So what happens if this output goes on? This will energize this relay. So this relay will be true because this is neutral connected here. Line is coming from here. So let's suppose this relay is energized by 220 volts. Okay, so this relay will be on, which will turn on this bit here. This is the relay contact. Okay, so if you know how does the relay works, it has a coil and it has a contact. If coil is on, contact will be true. If this contact is true, this line will travel from here and it will energize this lamp, which is connected to the neutral. So this lamp is generally an example of a load. Generally, lamp load is not more than 2 amperes, but in case if you have a lamp or any other device whose ampere rating is more than 2 amperes, you can connect like this. Okay, so this is the example of AC load without or below 2 amperes and above 2 amperes. So moving ahead, we have similarly DC loads up to 2 amperes. Same way you can connect that, but in case you have, now in this case you have 24 volts and 0 volts instead of line and neutral. So if you have a DC load more than 2 amperes, this is the same way. You have a relay, you can connect the relay using 24 and 0, and the similar way you can connect the outputs. So this is much similar, but you must note that if your ampere rating is less than your load rating, you must not connect it to PLC because you will damage your outputs. Okay, so let's move next. In the next slide, we'll see conversion of basic schematics into ladder logics, so that I will continue in the next video.